This lecture is about reading data from HDF5. HDF5 is used for storing large data sets. It's also used for storing structured data sets, and it supports storing a range of data types. The name HDF stands for Hierarchical Data Format, and that's because the data is stored in groups, which contain 0 or more data sets along with their metadata. Each of these groups has a group header with a group name and a list of attributes corresponding to that group. They also have a group symbol table, which has a list of the objects in the group. Data sets are then multi-dimensional arrays of elements along with metadata. They can have a header with name, data type, data space, and storage layout. And then they also have a data array, which is actually sort of the data frame, you can think about it, of the HDF5 element. If you want to know more about the HDF5 storage structure, you can go to the HDF5 group's website. So the RHDF5 package is actually installed through Bioconductor, and so the way that we're going to install this package is we're going to source this URL right here, and that will load the BioC-Lite function. The first time you install a package with BioC-Lite, it will also have to install the BioBase packages from Bioconductor, and so it might take a little bit. And so what we're going to do is use the BioC-Lite command to load the RHDF5 package. Then once we've downloaded the package, we can just load it with the same library command that we always use. In this lecture, we're going to actually create HDF5 files and then interact with them. You can actually just use the RHDF5 file package to access data and pull it out of HDF5 datasets without having to create them yourself, but it's sort of easier in terms of lecturing just to show you what it looks like when we create them ourselves. So we're going to use the h5 create file command to create a HDF5 file set, which is going to be example.h5. So this lecture is actually going to be modeled very closely on the RHDF5 tutorial, which can be found at this website here that I've linked to at the very bottom of this slide. So once we've created that HDF5 file, then what we can do is we can create groups within the file. So we use h5 create group. And so what that will do is it'll create within this file the group foo, and then we can create another group called ba, and create another group that is a subgroup of foo called foo-ba. And so what you can do then is you can actually see the groups and the names of the files that we've created if you look at h5ls. So it's like the ls command, but it's listing out only the components of this particular HDF5 file. So then what we can do is write to the specific groups. So for example, we can create a matrix A, and then we can use the h5 write command to write that matrix to a particular group. So again, this is the file that we're looking at, and then this is the group within that file. And so we can also write, we don't have to write just matrices, we can actually write multi-dimensional arrays. For example, here's a multi-dimensional array. We can actually make it add attributes. So for example, we can give it metadata like this, the leader attribute, which is sort of about the units. And then we can again use the h5 write command to write this array to a particular subgroup. And so again, if we list out what's going on inside this file now, we have all the groups that we've created, and also within those groups, we actually have some data sets. So you can see that A is now an h5 data set, and it consists of integers, and then there's another data set down here, B, which consists of floats, and it gives you the dimensions of those data sets that can be multidimensional. So we can write a data set directly. Also, we can write actually a data set to the top level group. And the way that we do that is, so suppose we create a data frame like this with the df command. So now we have this data frame up here. And so what we can do is we can actually use the h5 write command to write that data frame directly to the top level group. So instead of passing it the group that we're going to send it to, we can actually just send it the variable name. So then if we list out what's going on, we now see that in the top level group, sort of the root group, you see df, and it's a data set, and it gives you the dimensions of the data set and so forth. You can then read data using the h5 read command. So you're going to use h5 read, and you're going to tell it what file you're going to be looking in. And then, for example, you can tell it to read a very specific data set like this, read foo/a. You can read sub data sets with by just specifying the path like this. You can also read data set in the top level group by just specifying the data set name. And so what you get back out is the data that you wrote in. And so this is how you're going to read data if, for example, you have a data set in an HDF5 file and you want to get it out. Another advantage of the HDF5 file format is that you can easily read and write in chunks. So what we're going to do here actually is we're going to write again. So we're going to use H5 write, and we're going to be writing to the data set A that's inside of our file. And so what we're going to be doing is we're going to be writing the elements 12, 13, and 14, and we can tell it, well, we want to write it to that data set, and we want to write it to a specific part of that data set. So what we can do is give it indices. So the index file here will give you indices for each of the dimensions. So the first dimension, we're going to say write to the first 3 rows in the first column of this data set these values. And so if we read the data set after we've done that writing, you can see that in the first 3 rows of the first column, you get 12, 13, and 14, just like we wrote there. You can use a similar index command to read just a subcomponent of the data set as well. So you can pass it an index, which is a list that shows the different dimensions to read just, for example, if you just wanted to read the first 3 elements, the first 3 rows of the first column, you could pass the same index command to H5 read. So some notes and further resources. One thing to keep in mind is that HDF5 can be used to optimize reading and writing from disk in R. This tutorial here gives a lot more information about how to use HDF5. I've borrowed a lot of information for this lecture from that tutorial. And the HDF5 group has a lot of good information in general on using HDF5 if that's what you're interested in.